Hey guys, this is Mr. Middleton. We're going to talk about the isosceles triangle theorem today. Okay, um, this is another way that we can use angles and sides in a triangle. Another tool that we can put in our basket, our toolbox. There we go. Another tool we can put in our toolbox to use to um, do some proofs. So let's talk about what the isosceles triangle theorem is. Okay, first of all, we should know what an isosceles triangle is. Isosceles triangle has exactly two sides congruent. Okay, an isosceles triangle has exactly two sides congruent. If two sides of a triangle are congruent, then the angles across from the congruent sides are also congruent. So here we have an example of this. We have an isosceles triangle. Triangle STU is an isosceles triangle. You see that ST is congruent to TU. Those are the two legs that are congruent. SU would be referred to as the base. Okay, so since these two sides are congruent, using our isosceles triangle theorem, that's this here. This is the theorem. Okay. Then we can say that, okay, because those two are congruent, the angles opposite the congruent side should be congruent as well. So we can say if ST is congruent to UT, as it shows in the diagram, then angle S is congruent to angle U. Okay. Alright. So that should be easy enough. The markings, if you have any kind of trouble with it, the markings kind of point to the angles that should be congruent. Alright, now what I do want you to notice though is that the isosceles triangle theorem is a conditional statement. Okay, remember conditional is an if-then statement we talked about in the second chapter, second unit I guess. Okay, so let's write the converse of the isosceles triangle theorem. Okay, you can pause it and try it on your own, or you can do it with me. So the converse, remember, is when we switch the hypotenuse and the conclusion. So if this says if two sides of a triangle are congruent, then the angles across from the sides are also congruent. We can say if, say, two angles in a triangle are congruent, I'll just say triangle, are congruent, then the sides across from those angles are congruent as well. Okay. So basically what this says is, okay, maybe we're given this triangle that where we know the two sides are congruent, we can say, oh, that's isosceles. But even in the situation where we're given this triangle ABC, well, that was a squiggly line. Even in a situation where we're given triangle ABC, and they tell us, hey, A and B are congruent. Well, here, even though they didn't give me any sides, I can call this triangle an isosceles triangle. Because I should know, based on the converse of this theorem, I should know that the opposite sides then will be congruent. Okay, the sides that don't touch or don't make up the angle are going to be congruent to each other. Okay, since those angles are congruent. Alright, so it says use the converse of isosceles triangle theorem to write a conditional statement from the diagram. So basically they just want us to put this in words instead of just saying two angles. They just want us to be more specific since we have that information. And so in this problem, I'll say if angle P is congruent to angle Q, comma, then, if you haven't thought about it, think about it, what side should be congruent then? then RQ is congruent to PR. And you see that those are just the sides opposite those angles. Okay, so not bad. We will probably use this in order to prove some triangles congruent. And not necessarily just prove triangles congruent, but in order to do our proofs that we're asked to do. Okay, so here's one. Alright, so here it goes. It says plan your proof. Does it make sense to prove triangles congruent here? What do I need to show? Okay, so remember, I talked about this a little bit in class. We don't have to go step by step and write it out yet. We can kind of look at what they want us to prove and then look at our diagram and see what's our step or what's our process to get up there. So it wants us to prove that TRS is an isosceles triangle. Okay, so TRS is an isosceles triangle. Alright? So this is what I'm thinking. We will be able to tell that TRS is an isosceles triangle if, look here at this angle down here, if we could get this angle here to be equal to that angle there, or maybe T even, or T to be equal to that angle there, then we would have an isosceles triangle because we'd have two congruent angles, so we know that we'd have two congruent sides. So let's see if we can work up to that. Now looking at this diagram, I can kind of see that that should happen here because I have an isosceles triangle here in WVS since WS is congruent to WV. So that means I know that angle WVS should be congruent to angle S. So that's what I'm going to work towards. And this is fill in the blank, so I don't have a whole lot of freedom, but I should kind of know where I'm headed. So WV is congruent to WS. Why do we know that? It's given. Didn't have to work for it. Just writing it down. Number 2, it says angle S is congruent to WVS. So why is angle S congruent to WVS? Well, that's the converse. Nope, not the converse, sorry. That is the isosceles triangle theorem. Okay, the converse would actually prove sides congruent. Okay, this is the one that we were told, really. Okay, so that's the isosceles triangle theorem. We have it marked off now. Then it says angle WVS, okay, is congruent to angle R. WVS, R, how do we know that? It was given. Already drawn for us, not too much thinking, had to have it. Alright, here we go, transitive property. Remember, transitive property is the one that says A plus B, or sorry, if A equals B and B equals C, then A equals C. So here's what they told us. They told us that angle S equals angle WVS. They told us that angle R equals angle WVS. So since both of these equal the same thing, I can get rid of that middleman here, the WVS, and I can say, okay, angle S is congruent to angle R. See, I use the transitive property to prove those two angles congruent. Okay. And now, this next step has TR, this whole side, TR is congruent to TS. Why can I say that? Well, because this is an isosceles triangle now. Okay? Well, it's always has been. But we know it's an isosceles triangle. So, we're proving those sides congruent using the converse of the isosceles triangle theorem. Okay? So I'm going to mark that. Angle TRS is an isosceles triangle. Why? The definition of an isosceles triangle. I'll pause it. Actually, on the back there are believe, a couple more proofs, right? Oh, no, there's not. That's different. Okay, let's just do it. Thought there were a couple more proofs. I was going to have to pause it to give you another video so it wouldn't be so long, but we'll make it. We'll make it with this. Okay. So here we go. This is kind of more mathy. Says find the values of the variable in each problem. Number one's kind of tricky, but let's look at what we know. This is an isosceles triangle, right? Looking at this triangle, they're both matched or the same. So since this is 65, that means this must be 65. Okay, that's 130 together, so this is 50. I don't know if this matters, but we can write it anyway. These two are vertical angles, so that means this must be 65, right? Notice that this is also an isosceles triangle. So since this is 65, the opposite side has to be 65 degrees. Okay. And x is what's ever left out of 180. So 65 plus 65 is 130. 180 minus 130 gives us x, which is 50. Alright. Take a pause on number 2. Try it on your own if you can. Alright, so now looking at this, we can see we got two isosceles triangles here. We have this isosceles triangle, right, because the marking is there. So since this angle is 70, it makes this angle 70. Okay. They told us this whole angle is 90, so that means this angle 20 degrees. Notice also that this is a right triangle. Okay, you see it? So since that's 20, that means this must be, or this angle must be 20 as well. So that makes this angle 140 minus 20 minus 20. Sorry, 180 minus 20 minus 20, which makes x 140 degrees. Alright. We can do the same thing here. I'll go a little bit faster. Okay, so here we go. They told us that the perimeter triangle PRS is 26. So that means if I add x plus y plus 3 plus 3y, I should get 26. Only issue with this is, well, I have two variables. This is where knowing this isosceles triangle helps me though. Because you see that these two angles are congruent, whether they marked them this way or they put numbers there. Those two angles are congruent. So I should be able to say that, hey, x equals y plus 3. X is the same as y plus 3. How does that help me? Well, in this equation, I just said we can't solve it because we have two variables. What if instead of writing x, we wrote y plus 3 plus y plus 3 plus 3y? And now we can see what y is. So I have 5y plus 6 equals 26. That makes 5y 20. And that makes y 4. Once I can find that y is 4, I kind of already had an equation that we used. We had x is the same as y plus 3. Remember, because of our congruencies. So then I want to put x equals did we do that right? Yes, x equals, what's y? 4 plus 3. So x equals 7. Alright, couple things left. Alright, so corollary is an idea that follows directly for a proven theorem postulate. So that means if I say one thing and it's just like naturally follows, or like it only makes sense, then that's what a corollary is. It's like, okay, it only makes sense then that this thing also happens. Okay. So a triangle is equilateral if and only if it is equiangular. Okay, this is a biconditional meaning. It is true in both directions. Remember, we can say a biconditional if we did our conditional statement was true and our converse were both true. So I could say a triangle is equiangular if and only if it is equilateral, or I can say a triangle is equilateral if and only if it's equiangular. They're both true. Alright, so this is how it helps us. Because when we get a triangle like this, like in this problem, sorry, I'm trying to make sure I don't cover it all up. In this problem, this is an equilateral triangle. Okay, because it's equilateral, they told us that all the sides are the same. We can say, if it's equilateral, it has to be equiangular. So all those are 60. Okay, remember that helps us because now they told us that this angle is 90. So since this is 60, that must mean this is 30. Okay. This is 90, so that means 90 plus 30 is 120. M must be 60. Okay. And so angle M is 60. Angle N is 30. That's it. Hope it helps you out on your homework.